Object member functions in C++ make use of the keyword this to provide a pointer to the current object. Let's take a look at how this works. Make a working copy of class.cpp and paste it into our working project. And you see we have our very simple class here. I'll just go ahead and maximize this so you can see the whole thing. It has one data member I, and it has two public function members, which are setters and getters. They're accessors for setting and getting the value of I. We declare an object of class 1. We set its value and we print out its value. And when we run it, it looks like this. Value is 47. That's exactly what we expect here. So now we're going to go ahead and we're just going to add a function member here. We'll give it a void value and we'll call it look at this. And it'll take one argument and it'll be an int called I. And we'll just do the implementation down here. Void class 1 look at this int I. And we're just going to print out the value of I here. Printf. I is %d, like that. Now we'll come down here and we'll say object1, look at this, and we'll give it, say, a 9, like that. And now when we save this and compile and run it, you'll see I is 9, and of course the value down here in this get value is 47. This is an interesting result because you'll notice that our class has a data member called I, and yet we've passed an argument called I, and it printed out the argument. It did not print out the data member. So that's kind of what we would expect. The I from the local scope overrides the I from the larger scope, from the class scope. But what if we wanted to actually also be able to access the I from the class scope? We don't want to say class 1I because that's the class, that's not the object. What we really want is the object I, and that's done like this. So the this keyword actually gives us a pointer to the current object. And we can say here our object I is that. And so when I run this, we have object I is 47 and value is 47. So that this pointer can actually be really, really handy. It can be handy in circumstances like this. It can be handy when you're trying to do more complex things to get at objects within your own object. And it is actually a pointer to the current object. If I say printf this is, and give it a %p, which is printf's for print out a pointer. And then I also come down here and I say object1 is, and I give this object1, or the address of, like that. We'll need a semicolon in both of these places in order for that to compile and run. And so I will press the big green compile and run button, and we see our addresses that are printed out of those two pointers are exactly the same. So within the object, we're able to access a pointer to the object with the this keyword. So the this pointer is very useful in some circumstances. For example, when overloading an assignment operator, you'll want to return a reference to the current object so that your assignments can be chained. We'll see some examples of this later in this chapter. For now, let's delete the working file and run clean to get set up for the next lesson.